name is Antu, and today we will present about the comparison of two quantitative variables.
So this is our presentation about the regression of two quantitative variables. First, we talk about the outline, the clarified concepts. We have the overviews, then is the regressions, and finally is the correlation. About the overviews, people divide variables into two groups: qualitative variables and quantitative variables. To clarify the topic of the essay, here we will only deeply into quantitative variables. Quantitative variables include properties that we can weight and measure with measuring instruments. The measurements result of quantitative variables such as blood sugar, fluid weight, they are real numbers. In a population, we are interested into quantitative variable x and y. A sample is selected in the population, and the two quantitative variables x and y are two independent random variables obtained on each individual of the sample. Our question is whether there is any correlation between two quantitative variables x and y. Next is the regression. First is confirm the relationship between two variables. Then it predict or estimate the value of one variable from the values of one or more other variables. For example, predicting blood measures based on age, weight. The idea of the regression was introduced by the British scientist Francis Galton, first introduced in research on genetic human form. The third is the correlation. Correlation is a big problem in research. More research in the medical industry can be divided into two groups: research whether the two phenomena are related or not, research whether the two phenomena of interest are different or not, and evaluating the correlation of two variables x and y is to consider three aspects. First is the acceptance, second is the strength, and finally is the direction. Measure the strength of the relationship between variable numbers together. Next, we will talk about the linear regression models. Need to make a prediction or estimate the value of the variable from the value of one or more variables. The researcher can provide a mathematical model or applied model to analyze the populations. Is the model, or at least an approximation, representative of that population? That model is the best representation of the population in interest. Assumption of the linear regression model. The value of the independent variable x is said to be fixed. This means that the value of x are pre-selected by the investigator, so that when data is collected, they are not allowed to vary of these pre-selected values. Variable x is measured without error because there is no perfect measurement process. This means that the magnitude of the measurement error in x is negligible. For each value of x, there are subset of y values. For the usual inferior produce of the estimation and hypothesis testing for the values, these subpopulations must be normally distributed. The variable of the substitution of y's are equal, and they are denoted by the square sigma. It means value of population y on line on the same straight line. It's called the linear assumptions. This assumption can be expressed as symbolically: y equal beta 0 plus beta 1 plus x plus the epsilon. The y values are statistically independent. In other words, when varying the sample, assume that the value of I chosen at one value of x are independent of the value of I chosen at another value of x. The pictures is from this equation we can predict the value of I. The I mean dependent variable, the x mean independent variables, alpha mean intersection point of the vertical axis on the line I equal beta x plus alpha. The beta mean the slope and the alpha mean the error value. This is another picture. So the question is, when x increase or decrease, in what direction does it change? So there can be one small example from practical observation. If the father is tall, his other son is usually also tall. Are the heights of the father and his son related? To solve the above question, we have a survey on a sample of the father and the son pair, randomly selected from a population. Measure the father's height x inches and the other son's height y inches. As you can see, there is a table. From the data table above, through the support of computers and software, we can find the regression equation for this problem as y equal 25 25.825 plus the 0.476x. This is the picture form mean the scatter plot x and y. From the chart above, it can be seen that as it increases, it also tends to increase. We can make a preliminary assessment from the correlation between two variables thanks to the scatter plot. So that what is a scatter plot? About the scatter plot, I will invite Thuyết to present this for you.
Okay. Hello everyone. Welcome teacher and everyone to this part. And right now, I will present this content on the topic of scatter plot for you. Okay, I will start now. Everyone focus on it. Scatter plot is marked points with coordinates xi and yi, called sample points on the perpendicular coordinate system. The above set of sample points is called the scatter plot or scatter diagram. The scatter diagram like an ellipse. The sample points xi and yi seem to be around a straight line. The major axis of that ellipse. And then this is predict that x and y have a straight correlation. If the slope of the line is positive, then x and y are positive correlated. But if the slope is negative, then x and y are negatively correlated. The scatter diagram has a circular shape. We say x and y are uncorrelated. The sample points appear to be around a curve. We say that X and Y are not linearly correlated, or we can say non-linear. Finally, of this part, I will have a note for you. Remember, you must draw a scatter plot to have a reliable assessment of the correlation of two variables. That's all. And next is part 4, sample correlation coefficient. The correlation coefficient measures the degree of correlation between variables X and Y. We don't stop at the scatter chart. We also have to rely on the correlation coefficient to confirm our scientific research results. It also tells us whether the direction of the correlation is positive or negative. Next, I will have some example for you. For example, first, body mass index. We can call it the BMI and body fat percentage. The higher your BMI, the higher your body fat percentage. Or height and weight. The taller you are, the heavier you are. It is positive correlation. And I will show you the symbol of correlation coefficients. We use the word R to show it. Formula to calculate correlation coefficients are. You can see this picture. Okay. And next, I will tell you the meaning of correlation coefficient R. R represents the correlation of two variables X and Y. Value of R belong from -1 to 1. If R equals 1, then X and Y are completely positively correlated. If R equals -1, then X and Y have a completely negative correlation. And if R equals 0, then X and Y are uncorrelated. This means that there is no linear association between X and Y. If R is close to -1 or +1, there is a strong linear relationship. When R is close to 0, correlation is weak or non-existent. Okay, right now, in the screen, you can see some picture about the correlation coefficients. The picture A, it presents the perfect positive correlation equal +1, slope positive. And the next, picture B, is presents perfect negative correlation R equal -1, slope negative. And the picture C, positive correlation from 0 to 1, slope negative. And negative correlation from -1 to 0, slope negative. You can see it. The difference of picture C and picture D. In the picture C, R equal 0.874, and picture D is R equal -0.874. Similar in the picture E, no correlation, and R equals 0. F, no linear correlation, R equals 0. And right now, I will show you the description of strength of correlation. and the clearly rate of it. If you see it's strong, the range of it is from 0.8 to 1. If it's good, it's smaller than 0.6 to 0.8. If it is moderate or modest, it's smaller than from 0.3 to 0.6. Final, if you see it weak, it may be from smaller than from 0.1 to 0.3. Yeah, you can see it. And in the example above, we can calculate R equals 0.704. So X and Y are positive correlated. Let's try example 2. Research on drug excretion after taking it for a period of time. Let X is hour be the time when taking the drug, and Y is 3 on ml be the drug concentration at that time. Observing X and Y many times, we have the following result. In the row of X, we can see number 1, 2, 3, 5, 8, and 10. In the row Y, we can see 0.9, 0.8, 0.75, 0.7, 0.5, and 0.4. We can calculate R equal minus 0.992 smaller than 0. So X and Y are negatively correlated. And next, we continue with the coefficient of the determination used to evaluate the level of explanation of the linear regression model with real data. It shows the percentage of variations in dependent variable Y that is due to independent variable X. We can see on the picture R the square of R is from 0 to 1. Square of R close to 0. Data are not compatible with a straight regression line. And square of R close to 1. The data is well compatible with the regression line. This explains that a large part of the variation in the dependent variable. You can see this picture. Picture A, close fit, large, square of R. In the picture B, poor fit, small, square of R. The bit C, square of R equal 1. Bit D, square of R equal 0. In example 2, R equal minus 0.992, and we can see that square of R equal 0.984. That means that 98.4% of the variation in Y is due to X. And Next is regression variation. Measures the dispersion of points xi and yi around the regression line. This is the formula of it. The square of x, y, x is small, then the points xi, yi line close to the regression line. The square of x, y, x large. The points xi, yi line scattered on the regression line. X, y, point x is called the standard deviation of the regression variation. And this is two formula of regression variation. This is for example 3, we have a regression equations y equal minus 0.053x to plus 0.93, which is equal 12 e equal minus 0.053. Okay. Monty 12 plus 0.93 and is equal 0.306. And you can see it. This is the equation. And beta is equal minus 0.053 and alpha equal 3 and R is equal minus 0.992. And the formula we can, by use for the formula we can calculate is equal 0.027. For example 3, model summary B. There in the model 1, R equals 0.992. You can see in the picture. And next, test the correlation coefficient. When calculating the sample correlation coefficient are different from 0, but we still have to test whether X and Y in the population are really correlated. Yeah? So make assumptions. You can see in the picture. When H0 is true, then T will equal. Yeah? You can see it. The formula of it in the screen. With the result in example 1, is the head of the father and son really correlated? Yeah. Use the formula and calculate it. With this formula equal 2.23, H0 should be rejected and HA accepted. The threshold alpha equals 0.05. Finally, conclusion: X and Y are actually correlated at a moderate level. Threshold alpha equal 0.05. This is a positive correlation. And next is confidence interval for focus, Y and mean of focus, mu y. After proving that X and Y are indeed correlated, we find the confidence interval in the population. Confidence interval for focus, y calculated according to the formula. Confidence interval for focus, mean of focus, mu y calculated according to the formula. In example 3, y equal minus 0.053x plus 0.93, which is equal 12. E equal 0.295, and the gamma equal 0.95. So C equal T 0.05 for equal 2.776. 95% confidence interval for y when it's equal 12. Can't see it. Solution: with is equal 12, the value of y will lie within this range. And if 95% confidence interval for mu y when it's equal 12, test the regression coefficients a and b in equation y equal beta x plus alpha. Constant errors of a and b, SEI and SEP respectively. We have the formula. Okay. For regression coefficient beta, slope coefficient H0b equals 0 and H1b different from 0. T equal beta on SE beta, student n minus 2. For regression coefficient beta, slope coefficient, H0a equals 0, H1a different from 0, and T equal alpha on SE alpha, student n minus 2. Solution: and then H0 should be rejected.